All right, welcome back to what I can only hope are good choices. Mic check 1 2. Everything's looking good there. There's so many times it's just like I do a video and it's like the best video I've done in a while. And now the mic wasn't running. So yeah, so making good choices here, learning how to do this. Like this is a valuable skill. I urge anyone, um, watching this. Um, if there's anything you're interested about, passionate about, pin up a few tutorials, like post it up somewhere, even just on your share it with your friends, like because this is a modern day. This is like the new reading and writing. Like you've got to figure out how to have that confidence to speak across space and time. I think that's really important. All right, so let's move on to lesson one of 103.7. So we're still on the topic of GNU and Unix commands. GNU and Unix are two different things. You'll have different commands in GNU. GNU is kind of like a bootloader. You can think of it that way. Like when you have multiple operating systems and it pops up to that menu and you can select between the two of them. That's GNU. Unix is more like Bash. GNU is you don't execute commands in real time to GNU on the Bash shell, as far as I know. I think you can set up like preparatory commands or like configure files for it, but I think that's the difference. And we can ask the AI. I'm kind of interested to ask the AI. And let's ask the AI. Why not? All right. So overall, as broadly as possible, explain the difference between GNU and Unix commands. For instance, would it be accurate to say that GNU, that one key difference is that GNU commands are issued at the bootloader screen, but Unix commands are issued at the bash command prompt? So the difference between GNU and Unix commands is not primarily based on where they are issued, but on their origins and characteristics. Here's a broader explanation. So good thing I covered this because I didn't really have it down. So number one, origin, GNU commands. So GNU stands for GNU is not Unix, and it refers to a collection of free and open. Oh, I remember this. Open source software tools and utilities that aim to provide a Unix-like operating system experience. GNU commands are typically found on Unix-like systems, including Linux distributions, but they were developed independently to be compatible with Unix. So like this is like the spirit of this channel. Like this is what I love about like these open source efforts. It's like what is the difference between GNU and Unix? Well, when it comes to how they were developed, there's all kinds of difference, but if the question is what is the difference between the intentions of GNU and Unix, there's no difference. They're intended to do the same things. It's just GNU is meant to be an alternative to Unix. So Unix commands are the original set of commands developed for the Unix operating system, which was created in the late 1960s at AT&T's Bell Labs. These commands are the foundation of the Unix-like operating system, including Linux. So, like, you mash up the best of both worlds. All right. So, compatibility. Unix commands are designed to be compatible with, not Unix commands. GNU is not Unix. Are designed to be compatible with Unix commands, but often include additional features and options. They are commonly used on modern Unix-like systems, and many Linux distributions use GNU utilities as their default command line tools. Alright, so compatibility of Unix commands. Unix commands are the original set of commands developed by Unix. While they are still found on many Unix-like systems, they may not have all the features and options found in their GNU counterparts. Alright, so then usage. Both GNU and Unix commands are typically issued at the command prompt, also often referred to as the bash or shell prompt, once the operating system has booted. These commands are used for various tasks, including file manipulation, process management, system management, and more. So in summary, the key difference between GNU and Unix commands is not where they are issued, but rather their origins and characteristics. GNU commands are, so both of them are issued in bash. GNU commands and the functionality of each is blended. So like their strengths are used, and then their weaknesses are tossed. So like if GNU has a strength in something and Unix has a weakness in that same thing, then GNU will be used, and then vice versa. GNU commands are a modern open source extension of the Unix command set, designed to be compatible with Unix, but often offering additional features. The Unix commands are the original set of commands developed for the Unix operating system and are still used on Unix-like systems today. Both sets of commands are issued from the command prompt within the operating system once it has booted. And I want to say one more thing about why I recommend doing this sort of thing, like making videos and tutorials. It's a workout. Like, if you go back and look at some of my old videos, like, you know, it was harder for me to speak, and my voice kind of didn't sound the same. Now, granted, I'm using different audio equipment, but, you know, it's exercise for your voice, for reading out loud, and that's all really beneficial. Getting that clear, crystal clean radio voice is something you just gotta exercise, and you can do intentional exercises. You can hire a voice coach, but if you've got that foundation, you've been doing it for a while, you're probably gonna get a better bang for your buck if you want to get a voice coach later. So like, I feel like my voice and my like confidence and ability to speak without like my voice giving out or like squeaking or something has improved tremendously since I started this channel. All right, so let's go. So tell me, or show me 5 examples. 5 examples each of GNU and Unix commands. Alright, so yeah, so here are 5 examples of both GNU and Unix commands. So GNU commands, ls, then we got grep, we got tar, find, and nano. Oh, so we've got okay. So these are all the same. Okay, so they are a little bit different. We can see the text editor here is ed. I wonder if I have that on the lab. Let me see. So, oh yeah, you know what? It's taking standard input. So yeah, it's on there. So let's do a quit, exit, escape. Okay, I don't know how to quit out of it. We can do a Control Z, and then we can do jobs, and then we can do kill by the job number, and there we go. So let's make sure that that's gone. It is, and we'll do a ed help. There we go. So now we have a. Now this is interesting because it says it's GNU, but anyways, not that important. That they're overlapped anyway. It's just a historical thing. It really doesn't matter in the modern world that much. All right. So objective. 103.7. Search text files using regular expressions. And then there'll be 2 lessons. Introduction. String searching algorithms are widely used by several data processing tasks, mic check, so much that Unix-like operating systems have their own ubiquitous implementation, regular expressions, often referred to as REs. Regular expressions consist of character sequences that make up a generic pattern used to locate and sometimes modify a corresponding sequence in a larger string of characters. Regular expressions greatly expand the ability to write parsing rules to requests in HTTP servers and Nginx in particular, write scripts that convert text-based datasets to another format, search for occurrences of interest in journal entries or documents, filter markup files, keeping semantic context. The simplest regular expression contains at least one atom. An atom, so named because it's the basic element of a regular expression, is just a character that may or may not have special meaning. That's awesome. That's awesome. I love that. Most ordinary characters are unambiguous. They retain their literal meaning, while others have a special meaning. Oh, that's so great. See, because like one of the hardest things to remember about regular expressions is that, you know, this concept of an atom. It's like it matches character by character. So for each character you want to match, you need a regular expression. I mean, you don't. It's like, well, yeah, like that. You know, so it's not that you need a regular expression. No, it is the case, because each character is an atom, and then each atom has a regular expression applied to that atom. So if you just have a, like the letter A, like if we were to match on this, you know, each of these characters requires its own regular expression. And where do you put the regular expression? You put it right there where the character is. So the regular expression for this character is a static hard-coded A. That's it. Now we could have other regular expressions. We could have a dot, so that this could be any character. We could have a caret before this, so it'd be like it'd be a, but that's an atom too. You know, this is an atom, and it's an atom that has special meaning, and the meaning means the beginning of the line. That's what you're matching against. And then here's another atom, $. So like like it gets confusing because you're matching against these characters here, but then you have, you know, 5-6 characters, and it's like, what is going on there? Why are there more characters than the characters I'm trying to match? And the answer is, there aren't more characters than the characters you're trying to match if you include a caret and end with a $, because those are atoms, and atoms have regular expressions applied to them, and the atom is the beginning of the line. So that's a regular expression that is the caret. It has a special meaning, and it means the beginning of the line. So like that. So those are atoms. So to match this atom that only is at the beginning and the end of the line, you need 7 atoms instead of 5. So those are just basic elements of a regular expression. And where it gets really confusing is, let's say you want to match a range of characters in this T, like T through P, Q, R, S, T, Q, R, S, like T through S. Now you need 1, 2, 3, 4, 5 different characters to do that. You need a bracket, you need a T, you need a dash, you need an S, and you need an N bracket. So that is one atom. Like, that's where you have to remember that what regular expressions consist of is at least one atom, and each atom is its own regular expression. So it's not something that you use to match a whole chunk. It's something you use to match each element, each atom in the chunk. All right, so dot atom matches. So this is an atom. This is the dot atom, and what it does is it matches with any character. Now this is the caret atom. So this is an atom that matches with the beginning of the line. So if you wanted to match any characters after that, you would need this extra one. And the thing is, this is one atom, so you're only going to match one character. And then here's another atom. This is the dollar sign. And this is an atom that matches with the end of the line. So great lesson already, like, because I've been like really confused about regular expressions, and actually recently I had a case where like what I was doing was wrong because I was, forgetting that each element of the text you're matching is its own atom, and you apply the expressions against that atom. So I just wasn't like very quick when it came to like writing out a regular expression. So like this is exactly what I'm looking for in doing the LPIC. It's just like filling in all these fundamental gaps in like what I know more broadly. Okay, so for example, the regular expression BC, composed by the literal atoms, so these don't have a special meaning, they just mean B and C. So composed by the literal atoms B and C, can be found in the string A, B, C, D. But cannot be found in the string A, 1, C, B. The also important thing to note is that it couldn't be found in the string A, C, B, D. Neither could it be found in the string A, B, D, C, because we're matching these two characters one after the other. So on the other hand, the regular expression dot C, so this regular expression has two atoms. The second atom has no special meaning, it's just C, but the first one does have a special meaning. Remember what that is up here. It means any character. So the regular expression dot C can be found in both strings A, B, C, D and A1, C, D, because these are characters. As the dot matches with any character. Now, character is an interesting word because characters can have special meanings. So that is a point of confusion. Hopefully that will be addressed somehow later on. The caret and dollar sign atoms are used when only matches at the beginning or the end of the string are of interest. For that reason, they are also called anchors. For example, CD can be found in A, B, C, D. And we see that here. But caret CD cannot, because we're trying to match against a new line atom, and these do not exist after the new line atom. Each of these atoms occur after these two atoms, and not directly after a new line atom. But caret CD cannot. Similarly, AB can be found in A, B, C, D, but AB dollar sign cannot, because the dollar sign is an atom, and it's an atom with a special meaning. And the special meaning is the end of the line. And there is no A and B have arguably three atoms, but in this case I only arguably three, because it always has that end of the line. But after A and B we have C and D. We don't have the end of the line, so there's no match here. So the caret is the literal character except when at the beginning, and dollar sign is a literal character except when at the end of a regular expression. That's important to know. So let's say that we were matching a dollar sign B. Would we have a match for that? We would not. But let's say we have a dollar sign B, C, D. Would we have a match for that? Yes, we would. Likewise, But if we had A, B, $CD, would we have a match? No, we would not, because this is at the end, so it's a special character. It's not a literal character. It's only a literal character if it's not at the end. All right, so bracket expression. There is another type of atom called bracket expression. Although not a single character, brackets, and this is where it gets confusing because you have to remember what the basic unit of a regular expression is. It's an atom. How many characters does an atom have? Well, it depends on what you're doing. If you're just matching a literal character, it has one. Even if you're matching a special character, like the end or beginning or end of the line, one. But that's not always the case. An atom can have more than one character, and we're going to read about that right now. So there's another type of atom called bracket expression. Although not a single character, brackets, including their content, are considered a single atom. There you go. I'm going to do a golf clap for that. That's what you got to remember. And that's where it just all goes wrong when remembering how regular expressions work. So a bracket expression usually is just a list of literal characters enclosed by the bracket, making the atom match any single character from the list. For example, the expression 1b, now here's where it gets even more tricky, can be found in both strings ABCD and A1CD. Now, why is that? Let's think about that. So this is an atom. So that's applied against a string, what you're matching. So like there's two things you're dealing with. You're dealing with the string that you're going through to try to find matches for, and then you're dealing with the regular expression you want to use to find matches in that string. And the regular expression is what contains atoms. The strings just contain characters in the string. So you use those atoms in the regular expression to find matches in the strings. In this case, we have one atom, and the atom is open close brackets, and then 1 followed by a B. So this has four characters in the atom, but it's still one atom. And what the atom is match either a 1 or a B. So let's look through the strings and let's check each character of the string for a match of the atom. So A, does that match the atom? No, I don't see a 1 or a B. All right, next character in the string, B, does that match the atom? Yes, it does. We got a B right here. There's a match. And so on and so forth. So the next one, A, does that match the atom? No, it does not. 1, does that match the atom? Well, yes, it does, because in this one atom here, we've got, it can either match a 1 or a B. So where it gets confusing is you can have extra characters on either side, and you can have, for example, if I put the letter A here, now I have a 2-atom regular expression where I can match either 1 or B, and then it has to match A. So great lesson. Wow, I'm actually really, really impressed by this lesson so far. So to specify character, because I've never heard a regular expression atom before. Like I've never heard it called an atom ever until now. And it's like that is the missing piece of the puzzle for me. It's like I need to call like whatever. Like I knew that thing existed. Like I knew that regular expressions contained atoms, but I didn't know it explicitly. I just kind of like half knew it and like I didn't have a name for it. It's like not knowing the name for rain and like it raining all the time and being like, what is this thing that I see all the time where I like can't go outside without getting wet, and it's like, when does this, it's like, oh, it's rain. If you watch a weather report, look for rain and you'll be able to tell. So it's like this is mind-blowing, game-changing for me. So to specify characters the atom should not correspond to, the list must begin with a caret. Now remember the caret, the new line symbol. So this is where regular expressions are even more tricky, because depending on the atom, the character in the atom might have different meanings. So if the atom, let's say, is just this caret on its own, and then just regular literal characters afterwards, then this means the beginning of the line. But as in this atom here, open bracket, caret 1b caret, the caret means something else. What it means is to match anything except the characters in this list. So it doesn't mean that it begins with 1 and B. It means that it matches anything except 1 and B. And now we've got a 5-character atom. So you can see how confusing it can be. So it is also possible to specify ranges of characters in bracket expressions using the dash. So for example, we've got a dash here, and we've got a 1, 2, 3, 4, another 5-character atom. This is 1 unit of a regular expression, 1 atom of a regular expression. So for example, bracket 0-9 end bracket matches digits 0 to 9, and bracket 0-z end bracket matches any lowercase letter. Ranges must be used with caution, as they might not be consistent across distinct locales. And I don't know what that means, so let's ask the AI. Ranges might not be what? Consistent? Oh yeah, consistent. Okay, so what does it mean that ranges might not be consistent across distinct locales? Restate this in clearer and simpler language and provide some examples. What a world we live in. Seriously, it's the future. So when it's mentioned that character ranges might not be consistent across different locales, it means that the definition of what characters are included in the range can vary based on the language or regional settings of a computer or system. Okay, so that makes sense. So like, let's say, for example, so in simpler terms, what one computer considers a range of characters might not be the same as what another computer thinks. For example, consider the range, so this is an atom. We'll consider it as an atom in a regular expression, and it's the range A through Z, lowercase, which typically represents all lowercase letters from A to Z in the English alphabet. However, in some languages or locales, there may be additional characters between A and Z that are considered part of the alphabet. So if you use, or there could be missing characters. So if you, well, in that case, it wouldn't be that big of a deal, I think. So if you use A through Z, it'd still be a big deal because you wouldn't match on that if you're trying to match on the missing character. So if you use A through Z in a regular expression on one computer, it might match only English lowercase letters, but not another computer with different language settings. It could match more characters than you expect. Another example is with digits. In most cases, 0 through 9 represents all the digits from 0 to 9. However, in some locales, there might be additional digit characters or even different symbols used for numbers. So if you use 0 through 9 in a regular expression, it might not cover all digit characters in every locale. In summary, when working with character ranges in regular expressions, it's essential to be aware that their interpretation can vary depending on the language or regional settings of the system. This can lead to unexpected behavior in pattern matching. All right, so that sounds great. So bracket expression lists also accept classes instead of just single characters and ranges. Traditional character classes are Okay, so it gets even more confusing here. So now we have an atom that contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's not even the longest one. Different characters that represent one atom in a regular expression. So what this does is it represents an alphanumeric character. So it'll be so when you apply this regular expression that contains just this one atom to a matching string, it will match if there is an alphanumeric character. So A through Z and 0 through 9. All right, so the next one is alpha. So this is just alphabetic character, no numbers. Next one is ASCII. Represents a character that fits into the ASCII character set, and these are special syntax: open square bracket, colon, then the word that represents what you want to match, and then another colon, and then close square brackets. So the next one is blank, which represents a blank character. That is a space or a tab, which is interesting to note that it could be either or. So the next one is CNTRL, which represents a control character. Then digit, which represents a digit 0 through 9. Then graph, which represents any printable character except space. Then lower represents a lowercase character. Then print represents any printable character, including space. Then PUNCT represents any printable character, which is not a space or an alphanumeric character, such as punctuation, so like a period, a comma, exclamation point, question mark. All right, and then the next one is space, represents white space characters, space, form field, so that's \F, new line, \N, carriage return, \R, horizontal tab, \T, and vertical tab, \V. The next one is upper, which represents an uppercase character, and then X digit, which represents hexadecimal digits 0 through F. Alright, so character classes can be combined with single characters and ranges, but may not be used as an endpoint of a range. Oh, that's interesting. Okay. Also, character classes may only be used in bracket expressions, not as an independent atom outside of brackets. Yep, so that's a good point. If you do that, then it'll just match. Then you will have 1, 2, 3, 4, 5, 6 atoms for this X digit one. In order to have an individual atom of multiple characters, you need to use those brackets. All right, so next section is quantifier. So the reach of an atom, either a single character atom or a bracket atom, can be adjusted using an atom quantifier. Atom quantifiers define atom sequences. That is, matches occur when a contiguous repetition for the atom is found in the string. The substring corresponding to the match is called a piece. Notwithstanding, quantifiers and other features of regular expressions are treated differently depending on which standard is being used. As defined by POSIX, P-O-S-I-X, and we can look at what POSIX is later. There are two forms of regular expressions: basic regular expressions and extended regular expressions. Most text-related programs in any conventional Linux distribution support both forms, so it is important to know their differences in order to avoid compatibility issues and to pick the most suitable implementation for the intended task. And let's ask what POSIX is. I could just use a reminder. It probably was covered before, but so what is POSIX? All right. So POSIX, which stands for Portable Operating System Interface for Unix, is a set of standards and specifications that define the interface between a Unix-like system and user-level applications. The goal of POSIX is to promote compatibility between different Unix-like systems, allowing software written for one POSIX-compliant system to be easily ported to another. POSIX standards cover various aspects of operating systems and system programming, including API, Application Programming Interface. POSIX defines a set of system calls and library functions that applications can use to interact with the operating system. This ensures that common functions such as file I/O, process management, and inter-process communication have consistent interfaces across POSIX compliant systems. So next one is shells and utilities. I'm not going to read all of these. Then threads, file systems. So it's just basically like the standards that were developed to encourage portability and interoperability among Unix-like systems. So it's like the RFC, if you think of it, for like a network protocol or something like that. They're standards. They're called the POSIX standards. All right, so moving on here. The asterisk quantifier has the same function in both basic and extended regular expressions. Atom occurs 0 or more times. Now, this is where it gets even more confusing. So, the occurrence of an atom is an atom. If it occurs 0 or more times, and you want to match on that, you need an atom that matches on the occurrence of the prior atom. And that atom is the asterisk. So the asterisk quantifier has the same function in both basic and extended regular expressions. Atom occurs 0 or more times, the one directly preceding. And it's a literal character if it appears at the beginning of the regular expression or if it's preceded by a backslash. This is the escape character. The plus sign quantifier plus will select pieces containing one or more atom matches in sequence. With the question mark quantifier, which is question mark, a match will occur if the corresponding atom appears once or if it doesn't appear at all. If preceded by a backslash, their special meaning is not considered. Basic regular expressions also support the plus sign and the question mark quantifiers, but they need to be preceded by a backslash. Unlike extended regular expressions, plus sign and question mark by themselves are literal characters in basic regular expressions. Okay, so I want to understand that a bit better. So, okay, so this difference between basic and extended regular expressions is defined by the POSIX standards. So there are two forms. I'm not even sure if I read this. Okay, so there's two forms. There's basic and regular. Most text-related programs support both, so it's important to know their differences in order to avoid compatibility issues. So one thing I would like to say is, like, how do you pick between a basic... Yeah. So how do you pick between using basic and extended regular expressions? This isn't what I mean. So, no, what I mean is, what do you provide as input in order to select one or the other, and how can you determine which one has been selected? What? All right.
To select between using basic and extended regular expressions and to determine which one has been selected, you typically provide input through command line options or flags when working with regular expression related commands or tools in a Unix-like environment, such as Linux. Here's how you can specify and identify the chosen type. 1. Command line options. Basic regular expressions, B or basic regex. You can specify the use of basic regular expressions with a command line option like B or dash basic regex. For example, with the grep command. Bash. grep b pattern file.txt. Extended.
Okay, I'll stop that early. So basically, whatever program you're using to do basic expressions, you could use grep, you could use Python or whatever. It should be either selectable through the options you pass to that program, or it should be picked by default by that program. The default should be set by whoever designed that program. Okay, so next is bounds. A bound is an atom quantifier that, as the name implies, allows a user to specify precise quantity boundaries for an atom. In extended regular expressions, a bound may appear in 3 forms. All right, so the first form has curly braces and it has the letter I. And for this, the atom must appear exactly I times. I is an integer number. For example, we have an atom here. So what the atom is that's interesting. It's in kind of a weird syntax. Oh, I see. So here's the atom. So these here are not atoms. These are things. These are bracket expressions that you can use within an atom. Or these are character classes. So in order to use these, you need to put them into a bracket. A bracket basically says that this bracket and everything inside constitutes one atom. So here we've got one atom with all of these characters. You can see how confusing it truly can get. And the first part of the atom is that we're matching blank space. And then the second part of the atom says that we're matching a blank space exactly 2 times. So for example, the atom, and this is all one atom, matches with exactly 2 blank characters. So it's a one atom that matches with 2 characters. It can get confusing there as well. It's just confusing. I think regular expressions are not that Pythonic. Let's have a quick tangent on that. I think. So what is something that is Pythonic in the the Python programming language, and do regular expressions typically be something like that is Pythonic, or are they typically antithetical to a Pythonic nature?
Pythonic is a term used in the Python community to describe an approach to coding that makes use of Python's strengths and follows a philosophy which emphasizes readability and simplicity.
Yeah.
A code that is Pythonic is not only syntactically correct but also follows the conventions and best practices of writing Python, which are outlined in PEP 8, Python Style Guide, and in PEP 20, also known as the Zen of Python. Regular expressions, regex, are a powerful tool for working with strings, and Python supports them through its 3 module. Whether or not using regular expressions is considered Pythonic can depend on the context. In favor of being Pythonic: precision and efficiency. Regular expressions allow for precise and efficient string manipulation, which can lead to faster, more optimized code.
Yep.
Widespread usage. Regular expressions are supported in many programming languages, not just Python, and are widely used in programming, so having a mastery of regex can be seen as a valuable skill.
Okay.
Against being Pythonic: readability. Regular expressions can become very complex and difficult to read, especially for those not familiar with regex syntax, which goes against Python's philosophy of readability and simplicity. Complexity. In many cases, Python builds in string methods or other high-level operations, like using the str, split, str,
exactly,
replace, etc., can achieve the same result as a regular expression but with simpler, more Pythonic code.
Exactly.
A Pythonic approach often means choosing simplicity and readability over complexity, so when a regular expression becomes too complex or unreadable, it might be seen as unPythonic.
Right.
That said, in many cases, using a regular expression can be the most efficient solution, and if the regex pattern is not too complex, it can still be Pythonic.
Okay.
In summary, regular expressions can be both Pythonic.
Yeah, so so regular expressions can be both Pythonic and not Pythonic depending on how they're used. It's recommended to strike a balance, use regex when necessary, but avoid them when simpler, more readable solutions are available. it's always good practice to add comments explaining complex regular expressions to aid readability. So, well, my idea of regular expressions for most of my Python coding endeavors was that they were unPythonic. So I would use, splits, I would use replace, I would use these built-in string methods. I just manipulate my strings, match for things. And I wouldn't use regular expressions all that much. I've used them like sometimes, but definitely not in a very sophisticated way. And I would have lines of code that just have, these like multiple times, and that was Pythonic. Just having these, so many times stacked on top of each other. So like what I would do is like build out a function sometimes and then just pass the function. But this idea I had that regular expressions just are not Pythonic. Was wrong. What is Pythonic are conventions and best practices that are outlined in PEP 8 and PEP 20. And then what is also Pythonic is anything that is precise and efficient, and anything that has widespread usage. So I didn't think regular expressions were Pythonic because the complex ones aren't readable, and then the complexity of a regular expression is, in my opinion, sometimes it's like you can simplify it just by using the built-in Python stuff, but I was wrong. Regular expressions can be Pythonic depending on what you're doing with them. All right, so the next section is so bounds. We learned about this, so on to the next one. The next one is open curly brace I and then a comma and then close curly brace. The atom must appear at least I times. So I would be an integer number. For example, now here we have one atom, and this blank character that we're matching for. We want it 2 or more times. So it matches with any sequence of 2 or more blank characters. Now remember, this is the regular expression. Regular expressions contain atoms, and then in addition to a regular expression, we will have a search string, and search strings contain characters. So in this atom it will match with any sequence of 2 or more blank characters. All right, next one is open curly brace I, comma, and then J, and then close curly brace. So the atom must appear at least I times, and at most J times. So a min-max for your matches. I and J integer numbers. So you don't. This is important to point out when you do these atoms. These are just representations of the numbers you would plug in. So you can see in the example, we plugged in the number 2. The same thing for here. And then this is the fact that there's 2, that there's I and J, just shows that these are numbers used for different purposes. So I is used to create the minimum that it must appear, and then J is to define the maximum. So the atom must appear at least I times and at most J times. I and J integer numbers, J greater than I. For example, ooh, this is interesting. Ooh, this is fascinating. See, now this is where it gets really, really tricky. So my understanding of regular expressions is that each of these is an atom. So let's count the atoms. 1, 2, 3. So my understanding of this regular expression here, this is a regular expression, is that in the search string, there would be a match if the search string contained the pattern X, then a Y, and then the number, the letter Z at least 2 times in a row, but it could also be 3 or 4 times in a row. If it were 5 times in a row, it would not be a match. But my understanding is incorrect because, for example, this atom, or sorry, this whatever it is, I don't know if it's an atom or a regular expression, matches the XY string. Oh, no, I was right. Okay, it was just so. Okay, let me read that again. So, for example, okay, and let me make this a little bit easier. I'm gonna pull up a notepad. This might make it easier. So we have a string, boom, and then we have X, Y, Z, 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 and then we have more gobbledygook. So I'm going to put this out like that just to make it easier. This isn't, and this can be the regular expression actually, because white space, or sorry, let me slow down here. This can be the search string. So this is a string we're searching through. You can have white space characters in it. All right, so now let's write the regular expression, or the atoms in the regular expression. So the first atom is going to be X. The next atom is going to be Y. And then the next atom is going to be Z, with a min and a max defined. The min will be 2, and the max will be 4. So now let's go through the search string, and let's see for each character in the search string if there is a match of the atom, and then we'll see throughout this whole search string, are there any matches of the full regular expression. So no match there, that's a Q. Nothing, nothing, nothing. We're looking for an X. Aha, we found it there. So we're matching the first atom of our regular expression. Now let's see if it matches the second atom of the regular expression, which is a Y. Yes, it does. Okay, now let's see if it matches the third atom in the regular expression, which is a Z, at least 2 times, but no more than 4 times. So we have a Z. Okay, we have it 2 times, so it might match. Now we have it 3 times. Okay, that's good. We have it 4 times. Oh, but there's a 5th time. So nope, there's no match happening here. So, for example, this matches the XY string, and then after it does that, if there's 2 to 4 characters of the Z character, it will match. If there's an extra character or there's only 1 instance, it will not match. So in any case, if a substring matches with a regular expression and a longer substring starting at the same point also matches, the longer substring will be considered. Basic regular expressions also support bounds, but the delimiters must be preceded by backslash, colon, by backslash, and then there's, I don't know what this colon is here. Oh, I see. So, but the delimiters must be preceded by backslash. And then there's a colon here, and then it says backslash curly brace and backslash end curly brace. By themselves, yeah, so basic regular expressions also support bounds, but the delimiters must be preceded by backslash. So the delimiters are open and close curly braces, and each of them must be preceded by backslash. By themselves, open and closed curly braces are interpreted as literal characters. A backslash open curly brace followed by a character other than a digit is a literal character, not the beginning of a bound. All right, and let's look at the clock here. This is a really thick, dense lesson. The guided exercises are going to be crazy, I think. So if I'm at the hour mark, this might be like a 3-part video. Let me just take a break, and then and if I don't get back to it, I mean, we've only got 2 sections, and then we got the exercises. So like, I think cutting it before the exercises makes a lot of sense, but cutting it now is cutting it a bit too short. But I do need a break, so I'll be right back. All right, I had my break, and I'm gonna eat it too. So let's close this out, and then get to the guided exercises. It's gonna be a much better place to stop. All right, so next section is branches and back references. Oh my god. Okay, this is where like when I talk about what's Pythonic and what's not, like we're starting to get into where it's just undebatable that this is just not Pythonic. All right, so basic regular expressions also differ from extended regular expressions in another important aspect. An extended regular expression can be divided into branches, each one an independent regular expression. Branches are separated by the pipe key, and the combined regular expression will match anything that corresponds to any of the branches. For example, HE pipe HIM, see how confusing that is? Will match. So so how does the pipe even, like, let's say your search string was HEHIM, and you wanted to search for, well, I guess you would use a square bracket, right? So for example, HE pipe HIM will match if either substring, okay, I get it. HE or HIM are found in the string being examined. I understand this now. So basically what you can say is find a match for he, and then if you don't find that match, find a match for him. So it's an or expression. So if you find the he, great. Don't search for the him. If you can't find the he, okay, now search for the him. That's what that means. That's not that hard. So how many atoms do we have? Let's count them. So we have 1, 2 items in the first match we're going to find. So if we find that match, then we just got 2 atoms. But if we don't find that match, now we have 1, 2, 3 atoms. So that's how that works. Really not that complicated. So basic regular expressions interpret the pipe key as a literal character. However, most programs supporting basic regular expressions will allow branches with, oh my god, escape pipe. Now it gets really confusing, because normally the escape character is to escape something to a literal character, but now it's escaping it from a literal character to a special character. Wow. All right, so next is an extended regular expression enclosed in open close round paren, can be used in a back reference. So for example, this is one atom here. This is one atom. And this one atom will match any regular expression that repeats itself at least once. And we the reason we have that is because we grouped it. We used these round paren, and then we did a backslash, and then we did the number of times we want this to be matched, and we want it to be matched at least once. So, for example, this atom will match any regular expression that repeats itself. And it gets confusing because it's not matching a regular expression. It's matching a character string. Like, this is a regular expression. Like, this is... In fact, I want to ask the AI about that. So, is this training material? Is this paragraph conflating the term regular expression with the term search string? Is it accurate to say that a regular expression atom will match characters in a string? Or is the writing Or is it more accurate to say that an atom will match any regular expression
The paragraph you provided does not explicitly conflate the term regular expression with the term search string. However, it does discuss how regular expressions are used to match patterns within strings or text. Let's break down your questions. 1. Conflation of terms. The paragraph correctly distinguishes between regular expressions, often referred to as regex or regex, and the strings they are used to match against. It explains how regular expressions are used within a string to find patterns. While it doesn't explicitly define search string, the context implies that regular expressions are applied to search for patterns within strings or text. 2. Matching characters in a string. The phrase "a regular expression atom will match characters in a string" is accurate. Regular expression atoms are the basic building blocks of regular expressions, and they are used to match specific characters or character classes within a string. An atom can match characters in a string based on the defined pattern or criteria. 3. Matching any regular expression. The statement "an atom will match any regular expression"
exactly.
is not accurate.
There's a typo.
An atom in a regular expression is designed to match a specific pattern or set of characters. It doesn't match any regular expression itself. Regular expressions as a whole are used to match patterns within strings, but individual atoms are not intended to match entire regular expressions. In summary, while the paragraph doesn't explicitly define the term search string, it correctly discusses the relationship between regular expressions and the strings they are used to match against. It accurately describes how regular expression atoms are used to match characters in a string based on a defined pattern, but doesn't imply that atoms can match entire regular expressions.
Oh shit. Oh, I did not want to lose that. Let me ask it this. Are there any typos, especially in regard to words and language used in this paragraph? So are there any typos, especially in regard to words and language used in this paragraph, that could misrepresent what it means to represent regular expressions? Yeah, I think that's a good question.
The paragraph you provided appears to be technically accurate in its description
Aha!
of regular expressions
wait.
and back references.
Wait.
However, there is one minor issue with wording.
Oh, okay. No.
In the sentence, if more than one parent-sized sub-expression exists in the regular expression, they can be referenced with \2, \3, and so on.
There is an actual
The word
typo.
"exist" should be "exists" to maintain proper
All right, there's a
subject-verb
grammatical
agreement.
typo, but
It should read, if more than one parent-sized sub-expression exists in the regular expression, they can be referenced with \2, \3, and so on. This change ensures that the sentence accurately conveys that when multiple parent-sized sub-expressions are present, they can be referenced using numbers like \2, \3, and so on.
okay.
Apart from this minor grammatical correction, The content accurately represents regular
Let me
expressions
no.
and back
Let me go
references.
here. So let me ask the full thing. So what I'm gonna say is. Is there anything wrong with this sentence? I spelled sentence wrong, I think. Or I spelled it like prison sentence. Oh, there we go. So is there anything wrong with this sentence? Specifically, is it incorrect to say that the example will match a regular expression because the correct thing to say would be that the example, which is a regular expression itself, matches a string of characters, which is not the same thing as a regular expression. Yes.
You're correct. The sentence contains an inaccuracy.
Thank you for
A regular
validating me.
expression does not match another regular expression. Rather, it matches a string of characters based on the pattern defined by a regular
Exactly.
expression. So, the corrected sentence should read something like, for example, digit. One will match any string of characters where a digit is immediately followed by the digit. But the expression is a back reference to the piece matched by the first parenthesis.
Thank you.
Moreover, your adjusted sentence more correctly communicates that the regular expression is matching a pattern in a string, not matching another regular expression.
Yes.
It's generally good practice to be precise in describing what a regular expression matches, so this kind of correction helps avoid confusion.
Okay, I'm going to read that one more time because, you know, as I keep saying, this is freaking hard to learn. And it's not only hard to learn because once you get in the weeds, it's definitely unPythonic. And because of all the different ways you can do it, even if you're doing it in a way that is more Pythonic, it's also hard to learn because it's taught like absolute garbage. Like, and I'm going to read this out loud one more time. This is not the right, this is wrong. This is wrong. So the sentence, for example, this regular expression atom, which is what this is, will match any regular expression. Right there, that's wrong. No. It will match any character in a string that repeats itself at least once. That's what it will match. It will not match a regular expression. It is a regular expression. Regular expressions match characters in a string. Regular expressions do not match regular expressions. And you need to know that to understand regular expressions. You have to know that. So it's not just a trivial thing. It's misinformation that will make it difficult for you to use regular expressions. So I'm going to read this one more time. Then we're going to read this and go and try to close this out. Okay, so here was the question. So the question is it incorrect to say that in the example, is it incorrect to say that the example will match a regular expression? And let's read the example. So for example, this atom will match any regular expression that repeats itself at least once. Okay, so that's the relevant portion. So the question I had was, is it incorrect to say that the example will match a regular expression? Because the correct thing to say would be that the example, which is a regular expression itself, will match a string of characters, which is not the same thing as a regular expression. So the answer, straight from the AI motherland, you are correct. The sentence contains an inaccuracy. Thank you, AI. So people don't understand me, but AI and computers understand me. Oh my god. A regular expression does not match another regular expression. Exactly. Thank you. Golf clap. Rather, it matches a string of characters based on the pattern defined by the regular expression. So the corrected sentence should read something like, for example, this regular expression Adam will not match a regular expression. It will match any string of characters, which is not the same as a regular expression, where a digit is immediately followed by the same digit. Because the \1 in the expression is a back reference to the characters matched by the first parentheses sub-expression in the regular expression Adam. So got that? Is that clear? Hopefully it's clearer now than it was before. But I can't let that go. I have to harp on that because that's why it's hard to learn regular expressions. They're not hard. It's just they're complicated, and the language used to describe them is often inaccurate because it's conflating it's not making it clear the separate concepts. It conflates them all together and is inaccurate in the language it uses. So, moreover, your adjusted sentence more correctly communicates that the regular expression is matching a pattern in a string, not matching another regular expression. It's generally good practice to be precise in describing what a regular expression matches, so this kind of correction helps avoid confusion. And thank you. That is amazing. Okay, so now we're going to read this again. So an extended regular expression enclosed in open closed round paren can be used in a back reference. For example, this regular expression Adam here, which is what this is, will match any wrong character in a search string that repeats itself at least once, because the \1 in the expression is the back reference to the piece matched by the first parenthesized sub-expression. Simple, right? Parenthesized sub-expression. This sounds very simple and easy to understand. If more than one parenthesized sub-expression exists, and there's an actual typo here, it should say exists, in the regular expression, they can be referenced with \2, \3, and so on. So see what I mean? It's like, first of all, there's an actual grammatical typo in one of the most complicated concepts that have been introduced so far. And second of all, there's a semantic typo too, where it's impossible to understand what's going on if they don't use clear language that tells you what's going on. So the last part of this section, for basic REs, regular expressions, sub-expressions must be enclosed by \open round paren and \close round paren, with open and close paren by themselves ordinary characters. So you've got to escape them to be special characters instead of escaping them to be literal characters. The back reference indicator is used. So this is for basic REs. For extended regular expressions like we see here, we do not need to do that. They're just automatically special characters. The back reference indicator is used like in extended regular expressions. All right, so the next final section of this part of the video, hopefully I won't have a aneurysm and, hopefully I can stay calm in reading the crime scene. So searching the regular expressions. The immediate benefit offered by regular expressions is to improve searches on file systems and in text documents. The -regex option of command find allows to test every path in a directory hierarchy against a regular expression. For example, now let's read that again. For example, the regex expression, we see that plugged into the example here, of the command find. It's applying there. So this is just a option you can feed to this program. Find, whoever built this program included this as an option. And it allows you to test every path in a directory hierarchy against the regular expression. So Now let's think about this more clearly. So against a regular expression. So where in here is a regular expression? Ready? 3, 2, 1. It's right here in these quotes. All right. Now, hopefully you'll know the next question I'm going to ask. If you do, I'll give you 3 seconds to try. So 3, 2, 1. And if you don't, the next question I'm going to ask is how many atoms are in this regular expression? So I don't really know the answer to that. But I'm gonna come up with my own answer and then ask the AI. So I believe that there are one. No, there are. Oh, it's hard to tell if this is an atom or if these are two atoms, and this is a second atom that matches. I'm gonna say two on this, so I'm gonna say there's 1, 2, 3. And then this is its own atom because it's escaping it. We actually want to find a dot. So that now we've got 4, 5, and since I did that before, I'm going to go with 6. Let's ask the AI. So we're going to ask how many atoms are in the regular expression. And remember, we're talking about a regular expression. So let's get the answer.
The regular expression provided / backslash
No,
doesn't
stupid
contain any
AI.
atoms in the sense of atomic
Stop being
elements or
stupid.
particles.
Duh.
In regular expressions, an atom refers to the smallest unit of the expression, typically a single character or a character class.
Thank you. Yes, you are
In this
correct.
expression, 1 dot represents any character except for a new line. 2 / dot
Okay, so
represents a
their
forward
answer is going to
slash
be
followed by any
4.
character. 3 represents any character, dot, repeated 0 or more times.
Wait, what?
These are not atoms, they are combinations of characters and modifiers used to specify patterns in text.
That's stupid.
In regular expressions, atoms are individual characters, character classes, or groups enclosed in parentheses.
That's dumb.
For example, in the regular expression,
Screw that.
ABC, ABC, is an atom representing the exact sequence ABC. So, there are no atoms in the regular expression / backslash.
That's stupid.
It's a combination of various regex elements used to match patterns in text data.
I hate that. That's dumb. I'm going to say that. I hate that. That's dumb. The answer needs to be either 4 or 6, depending on if it's 1 or 2 atoms.
I understand the source of confusion, and I apologize for any misunderstanding. In some contexts, regex patterns can be analyzed in terms of atoms, where an atom represents the smallest unit of a regex pattern that can't be further divided. In this case, Asterisk is considered one atom because it represents a sequence of 0 or more characters. / represents a forward slash followed by any character, which can be considered one atom. Asterisk is another atom, as it represents 0 or more of any character. So, you are correct. There are a total of 4 atoms in the regular expression / backslash. Thank you for pointing out the clarification.
Yeah,
and I appreciate your patience.
I think the AI is just kind of messed up. Like, and let me do another mic check because that's the kind of day it is today. So this first answer was just silly. Like, no, these are atoms.
I apologize for the confusion in my previous responses.
Okay.
Let's break down the regular expression / backslash more accurately. 1 dot represents any single character, so it's one atom. 2 asterisk is a quantifier that means 0 or more of the preceding atom, so it's one atom. 3 slash dot
Yeah, exactly.
represents a forward slash followed by any single character, so it's one atom. 4 dot asterisk
Yeah.
represents any character, dot, followed
Yeah,
by
the answer
0
is
or more of
6.
any character, so it's one atom. So, you are indeed correct. There are a total of 6 atoms in the regular expression slash backslash. Thank you for pointing out the correction, and I appreciate your patience.
Okay. Now it's going to change this answer to 4.
I apologize for any confusion in my previous responses. Let me clarify.
Okay, it's just messed up. It's just being a broken thing because it's semantic. It just depends on what. Like, it's not a standardized answer. But I think it does make sense to think of it that way, to break it down into the atoms. And for me, seeing this as 6 different atoms makes a lot of sense. So, like, the reason this here is 1 atom, but this here is 2 atoms is because what we're doing is we're escaping this into a literal character to the period. But here what we're doing is we're having 1 atom that matches any character, and then another atom that matches 0 or more instances of the preceding atom, of the previous atom. So 2 atoms. All right, so what's the next question I'm going to ask? All right, 3, 2, 1. All right, hopefully, or if you're on board with me, you should know what the next question I'm going to ask. So the next question is, where is the search string? Because regular expressions match characters in search strings, right? So where is the search string in this? 3, 2, 1. Standard output. It's in the standard output of this find command. For each line of standard output, we're going to use that as a search string, and then we're going to use this regular expression here and all the atoms within it to find matches in the search string. All right, so what this does is it searches for files greater than 100 megabytes, 100 units of 104.8576 bytes, but only in paths inside the user's home directory that do contain a match with this regular expression that it consists of, I would say, 6 atoms. That is a / dot surrounded by any other number of characters. Oh, wait, what? Oh, right. So we're searching for a / dot, and we're doing that because of these atoms. So the first atom searches for anything, and then the second atom searches for the prior atom 0 or more times. And then the next atom is a /. So we see we got a match there. We found a /. And then the next atom consists of 2 characters, and it's just this literal here. And then the atom after that is any character, and then the final atom is the prior atom 0 or more times. So here we go. We found our match. So what this does is it searches for files greater than 100 megabytes, but only in paths inside the user's home directory that do contain a match. So here's our match. That is this surrounded by any number of characters. So that's what will match this, and then it doesn't matter if there's characters on the left or characters on the right. Our regular expression matches because we have these atoms here that say we can have any number of matches on the left and the right of any character. All right, so in other words, only hidden files or files inside hidden directories will be listed, regardless of the position of the / dot in the corresponding path. For case-insensitive regular expressions, the iregex option for the program find should be used instead. So here's an example of that. We've got a regex type passed to it post, so it's an extended regex instead of a basic. So that's how we determine. Because remember, I asked that before, like how can you tell if something's using basic or extended, it does what you tell it to do. So we're telling it to use extended here, and then we're making it in case insensitive with this second option that we're passing to the find application. And this is a pretty tricky one. Let's count the atoms in this one. Oh my god. So we're going to start with 2 because that's I think I've established that. I think that makes sense. So we've got these 2 here, and then we've got 3, 4, then we've got 5, 6. So that's easy. Then we've got 7, 8, 9, 10. So we have at least 10 atoms. But then how many atoms do we have here? So the answer is, it depends on what the match looks like. If there's a match here, and remember it's case insensitive, then we have 1, 2, 3, 4, 5, 6 atoms. But if we get through a string and we don't see a deja vu anywhere in these 2 strings, now instead we match here. So we have 1, 2, 3, 4, 5, 6. So we have more atoms here than we do there. So the answer is, it depends on what the characters are in the search string. If the characters, since we're using, this is not really one atom. It's more of like a expression within a regular expression, and the expression is try matching this, but if you can't, then match that instead. So in this example, the regular expression contains branches, so it's got a branch, and the branch is in parentheses, I think. Written in extended style. In standard style, you would have to escape these. You'd have to escape it from a literal character into a special character using a backslash, which is kind of funny. So in this example, the regular expression contains branches written in extended style to list only specific font files under the /user/share/fonts directory hierarchy. Extended regular expressions are not supported by default, but find allows for them to be enabled with -regex type postx-extended or -regex type egrep for extended. If you don't pass those, it's going to be standard. And to do this similar thing, you'd have to escape these characters with a backslash. The default regular expression standard for find is find utils-default, which is virtually a basic regular expression clone. It is often necessary to pass the output of a program to command less when it doesn't fit on the screen. The command less splits its input into pages, one screenful at a time, allowing the user to easily navigate the text up and down. In addition, less also allows a user to perform regular expression-based searches. This feature is notably important because less is the default paginator used for many everyday tasks, like inspecting journal entries or consulting manual pages. When reading a manual page, for instance, pressing the / key will open a search prompt. This is a typical scenario in which regular expressions are useful, as command options are listed just after a page margin in the general manual page layout. However, the same option might appear many times throughout the text, making literal searches unfeasible. Regardless of that, typing this regular expression, or more simply, you don't have to use this. This is the same thing. In the search prompt, will jump immediately to the -O section if it exists after pressing enter, thus allowing one to consult an option description more rapidly. So that's important, I think, to demo in my lab. So for example, this help menu here, if we pipe it to less, and we want to see if there's an option for -O, we can just do -O, enter. Oh wait, can we do that? What do we do? Oh, sorry. No, we have to push the forward bracket. There we go. And now we can do dash O. Pattern not found. Well, let's see if there's a let's see the dash H. And there we go. We've got a match right there for dash H. Let's do a man on ED. So the manual page is quite a bit longer, but we're still in that less prompt. So now we can do the dash H, and there we go. We found it there. We can also look. Let's look for just because I'm juvenile. Nope, didn't find it. Okay, so there we go. So I think that's it for this lesson. We learned something really important about regular expressions, and that's that atoms. That what is really important to know, and it's also really important to keep straight. Are you talking about the regular expression, or are you talking about the characters in the search string? Because there's the regular expression is not the search string. Those are two distinctly different things, and you need to keep track of which is which. Otherwise, you're just going to get confused about what is going on. So I hope that made that clear. And stay tuned for the guided exercises.